Okay. Okay, so we're recording. So this is Donald Wedding, and today is, this is the fall of 2020, and we have tonight a guest speaker, Matt Marzillo, who is an employee at Microsoft Azure, and he's going to be doing a talk about the Azure machine learning platform, and this is for the 401 and the 498 class. So Matt, take it away. We're really looking forward to this.
Yeah, sure. So really quick, a little introduction on myself. So name is Matt Marzillo. I have worked as a data scientist for probably maybe 8 years or so. And not coincidentally, I graduated from the Northwestern program around 2012 or 2013 or so. I think that's right. With at the time was the predictive analytics degree, now it's data science. But since then have had several different roles working in the data science capacity. And currently for the last 2 months, so I'm still pretty green at Microsoft, so go easy on me here. I've been working as what we call a cloud solution architect for data and AI with Microsoft Azure. So the focus of the call here today is going to be kind of just to go over a handful of slides and talk a little bit. I'll do a brief introduction into what Azure is. I mean, Azure is a huge cloud platform, as some of you may know, and then go specifically deeper into Azure machine learning. And then show off just kind of a little bit of like, what it looks like when you're kind of actually driving Azure machine learning. So you can kind of see what it's capable of, and then hopefully have some time for questions as well. So as I'm going through this, typically like interactive is fine, right? So unless you have something, a big question that you think might kind of like go into a complete different tangent, hold off on that. But feel free to jump in if you have any questions, if anyone who's live on the call has any questions. Feel free. So really quick, and this is actually just an old screen grab that I just kind of grabbed from the internet right before we jumped on here. It's kind of looking at like what is like the entire world of Microsoft Azure, right? So like in the world today, right, there's basically 3 big players in the cloud computing space. It's Microsoft Azure, it's Amazon AWS, and then Google's GCP. And with that, you get kind of a host of different services, right? Everywhere from like, different kind of what we might call like, infrastructure as a service, where you can actually stand up your own VMs and your own compute and things like that. We can kind of move things from like your bare metal servers onto the cloud, for different like actual software and platforms, right? So you can see here we have, so some of the heavy utilized ones are things like Data Factory that does like, it does integration and data transformation and things like that. Machine learning is the particular service that we're going to cover today, as well as like, kind of some more standard data warehousing things, as well as modern data architectures. Now, I don't know if it's on here, but we have data lake storage, which is kind of something that a lot of folks are moving on to. But the whole idea, right, is that you have this platform in the cloud that scales, right? And you're kind of using a lot of these services as like a bit of a utility, right? So you can organizations, small and large, can use them, and you're kind of paying for them as you use them and as you're getting value out of them. And that's one of the kind of the cool things about the ML suite of tools that Azure offers. So really quick, I like to show this. This is like a kind of a slide that I just kind of hacked together when I'm thinking about machine learning. And this is something that a lot of you guys probably know. This might be pretty kind of like common sense to you, but machine learning is a 2-step process, right? You got that step above the line where you're taking data, you're cleaning it somehow from disparate data sources, and this box in the middle probably doesn't do justice to this process, but you're training, testing, doing different visualizations, so on and so forth, building models, working with the business, and then hopefully eventually spitting out a model, right? And that's the idea, right? Is to get to something that's valuable. And I think that getting a model into production is one of the things that doesn't happen probably as often as we would like it to, for a number of different reasons. But the idea is that you should take a model from this part right here. You should register it, right? I mean, that's kind of good hygiene, is to make sure that you're kind of hosting these models. I should say hosting, but you're kind of putting these models in some sort of registry or library where you can kind of keep track of them. And then you're also creating some sort of productionalized model, and however that might be. And then you kind of lob it over this line in step 2. And then now it's actually kind of in some sort of pipeline, right? And there's this pipeline might not fit all use cases. In my experience, it fits a lot of use cases generally, right? You have some sort of process or scripts that's running, that's kind of collecting data, organizing it, using the model to enrich it with some sort of prediction, and then exposing that somehow to the business, right? So whether that's a reporting to the warehouse, whether you're actually sending reports, whether you're, it's like this is all kind of happening like on the edge on an actual like device, you can kind of expose there, or you have a dashboard. And of course, that's the Power BI logo right there, Microsoft's dashboard tool. That's generally the idea, or the way that we kind of think about machine learning, and it just kind of like motivates the different services that Azure has for building and deploying models. So first is this is kind of what like the hub looks like, right, for Azure machine learning. And what you'll see as I get into it is that there's a lot of flexibility, right? So right, like one of the great things about any of these cloud providers, and then I'm going to try not to be too salesy with Microsoft, is that you can kind of go cradle to grave right within them, right? So you can build your models in Azure, you can evaluate them, you can deploy them, you can monitor them all there. But if you just kind of wanted to build your models in R, Python on your local machine and just deploy them in Azure, that's an option for you, right? So there's a lot of flexibility in terms of like which of these services you're going to use and how you're going to use them. So additionally, and I'm going to show this screen too once we dive into it, but you have the ability, you can kind of see up here, you have notebooks, which is something that a lot of data scientists are used to doing right now. Is you're going to be writing scripts in Python or R and building your models and doing your iterations there. You have the ability to do that in Azure, right? So you're just doing it on the Azure compute rather than doing it on your own virtual machine or your own local machine. And then we also have these kind of like no code, low code options, which are becoming more and more popular with kind of like the democratization, I'll say that in air quotes, just because it's kind of a little bit of a swear word, democratization of data science. You can kind of really scale up and use these types of solutions here to do to be more a more efficient data scientist, or to like level up a business analyst and see like a data science type role. Additionally, you have the unified model management, right? So you have the ability to kind of like, this is that kind of centralized registry right there, where you can kind of like keep track and have lineage of all your models. And then actually, before I show that, you also kind of have down here your endpoints, right? And that's sort of starting to become the probably most common way to deploy a model, is to create like an API endpoint to deploy it as an application and then expose it via REST API. It allows for a lot of flexibility to kind of like basically just take your scoring data or your real-time data, push it over to that model that's an API via an API, and get results back. So I'm going to show this, and this doesn't this may. Don't get too hung up on this because there's kind of a lot going on here, but this is kind of a smattering of the different types of services that we offer to kind of handle the kind of two phases of machine learning, right? Model training and then also model deploying, right? And I'll kind of highlight the ones that we're seeing used the most. So like, step one, you're a data scientist, right? You're going to be training your models. Typically what we see, we don't often see a lot of folks using Azure Hdinsight, which is basically just a suite of, I would say like more legacy Hadoop tools. So it's basically like running R and Python and the other kind of Scala on top of the Hadoop framework to kind of build models. We don't see a lot of that happening. What we do see is people kind of either using our Azure ML services for developing machine learning models. Databricks, if you're not familiar with Databricks, it's generally this, it's a company that's kind of, it's all on top of Spark, right? So it allows you to kind of do different types of data engineering and model, predictive model building on top of Spark. And then also just typical open source tools, most commonly R and Python. And then from there, you're kind of, you're pushing that out to some sort of repo if you have a Git and things like that. And then you're doing model validation, deployment. Typically what we see that's happening, not in Hdinsight, but in Databricks, either manually or with something like Azure machine learning services. And then, once we can kind of test out the fact that the model works, we're storing that model, and you can do Cosmos DB. That's typically for like the only use cases I've seen that used for is like, you know, like TensorFlow or different like neural nets where you can kind of store that like big graph inside of a database like Cosmos. But typically what we're seeing is like, you know, you're storing it in machine learning, or you're storing it in some sort of repo. And then you're going to deploy it, right? You're going to deploy it. This is kind of like, you kind of throw these into one, these two buckets into one. So like, you know, when you can deploy it either via like an Azure function, you can deploy it into Databricks, you can deploy it via an API, or, you know, via an API that's on top of a Kubernetes cluster, which is like basically a fancy way to kind of containerize your models and things like that. And then right in the middle, you know, you have some sort of orchestration, right? So you have something that's like kind of scheduling these routines and scheduling the process and things like that. And Azure Data Factory, again, is one thing I mentioned before, is kind of the big one that a lot of our customers are using to kind of schedule and orchestrate different data engineering tasks. So whether that's with or without a predictive model, the Data Factory is a common way to do that. Okay, so that's it for the deck. And I'm gonna kind of move over to a browser and kind of show off a few things. But before I do that, are there any questions with what I just showed or what I talked through? Okay, cool. I will. I'll keep moving along. And like I said, I mean, you know, feel free to jump in as you have questions. Don't let me scare you. Okay. So this is what Azure Machine Learning Studio looks like, right? So this is kind of like the portal. You access it via a URL. But maybe before we dive into that, this is what like Azure Portal looks like, right? So like when I showed that first slide up, and you have access to all these different services and all these different things that you can create, this is where you do it, right? So once you have a subscription, right, it's basically a way for Microsoft to charge you. You can kind of go wild, right? You know, depending on what sort of limitations that your organization has on you. But you can come here and you can create a resource, and this is the way it all works, right? So like if you wanted to, you can stand up some sort of machine learning. Actually, it's not there. It's always kind of confusing. It's better to type it. You can stand up Azure Machine Learning right here. Let's go Azure Machine Learning right here, and what you'll do is you'll click create, and you'll have the option to start to kind of like define what this looks like, right? So, and I'm not gonna get too into the weeds here. This is kind of, and probably it's honestly probably a little bit, I'm probably a little over my skis talking through the details, but you have the ability to kind of define, you know, how big do you want this resource to be, right? How many nodes do you want it to have? What region do you want it to have in? And then you can kind of group together resources into a resource group, right? So you might have like this machine learning studio that you're standing up, and you might want a Databricks environment because you're going to kind of be going back and forth with them. You can kind of keep them together because you're working on the same set of use cases together. But everything is done right here via this Azure Services panel. You can see here, I was kind of earlier today, I was playing around, you know, creating some SQL servers and putting some databases inside of them and things like that. And then also important, you have the ability to kind of track your costs, right? And right from here too, you can set up different like kind of alerts to let you know if you're kind of going to run over. So we talked about before, like you have notebooks, automated ML, and designer. So really quick in the notebooks, and I'll just kind of bounce out here. I'll just kind of show you the example of what it looks like. It's like, oh, where did I go? Okay. See right here, I have an instance of our studio running right in on Azure, right? So this is an RStudio interface running on top of my first compute that I created in the West region. And as just like a matter of example, this is just kind of a script that I had put together that shows how I'm pulling files from my data lake, which is, I mean, data lake is just basically, as far as like I'm concerned, is interacting with like a file store, right? So I'm bringing over some files from our Amazon data lake storage. And then I have like a .rds, which if you're familiar is a way of kind of writing out an R model. And I'm taking these kind of a couple other configuration files and deploying them as like a finalized model to Azure, right? So this is kind of within a couple of lines of code here. at the end, what we wind up doing is registering this model and then creating a service that we can then deploy. And then I have a little script right here that shows you how I can kind of just easily create a JSON data set, right? This is kind of one record. It's a readmissions data set, and then predict against that and then get a probability of a patient being readmitted. So that's kind of like number one, right? You can kind of run notebooks right on Azure machine learning. The second thing you can do is run automated machine learning, right? And this is something that I actually, the company I was with before Microsoft is a company called Data Robot, that this is kind of their bread and butter. So I guess I've come over to the dark side of Microsoft, or maybe the light side it's called. And so either way, it's the dark side for machine learning, right? Because it's the automated stuff. What this does is it allows you to take like some historical data, right? So phase one of machine learning, take that historical data. You want to make sure it's in a nice clean tabular format with all your predictor variables lined up on your one target variable. And then you can kind of feed that to this automated machine learning, and it'll automatically create many models for you, and then allow you to select the best one, right? So I can kind of quickly walk you through an example. So if I go to new automated ML run, I have a few data sets in here, and I have this bank trim. And this is going to give you a quick profile of the data set, right? So this example is customers of a bank, and we have certain pieces of information on them, their age, their job, and then some piece of information of what was going on in the market at this given time. So this is a kind of some comparison of year-over-year employment rate, consumer price index, consumer confidence index, so on and so forth. And then what we're doing is we're trying to cross-sell them on personal loans. And this Y variable here is telling us yes or no whether or not we converted these customers on whether or not they bought that personal loan. So these are data sets that I preloaded. You can also kind of load data sets here. And really, like, this is a kind of a similar setup as a lot of these types of tools, is you can kind of pull them in from a local file, get them from a data store like Azure Data Lake, or something on the web, or from some sort of open data set that you might have on Git or something like that. But let's just kind of use this bank trim one that I already showed you, that I already have in here. So if I click next, so what we call them is like an experiment, right? So it's like it's just basically a run, and I'll just say like demo 2020 1118 to define a new experiment. And then if I come here to the target column, I have to select one of the variables. We already said this Y is our target variable, and then it's got to run on somewhere, right? So we have this AutoML cluster that I had previously set up, and if you hadn't previously set up, you can kind of just create a new compute right here. Really easily, just by kind of filling out a few things, just whether or not you want to use CPUs, GPUs, so on and so forth. Kind of gives you kind of a quick idea of like how much you're going to pay. And when I talk about the scale, right, you kind of see here, it's not really that expensive, right? You're talking about, these are kind of some of the smaller ones, but as long as you're smart about turning them off, you're talking about $1 an hour or so for kind of running these. It's not too bad. So we'll say leave because I already have a compute. Cancel. Okay, so we have that, and that's really all that I necessarily have to do. But there are a few additional things that we have to pick whether or not it's classification, regression, or time series. In this case, it's a classification problem. If you have text, or if you have a kind of a big sparse file, enabling deep learning is always a good idea. Or if you have the appetite to let it run for a little bit longer, you can enable deep learning. But you can kind of just click finish here and let it run, right? And what it's going to do is it's going to go through the process of like splitting the data up into different folds for training and validation. It's going to evaluate them based on whatever configuration was automatically set, and it'll do its thing, right? It's going to say, okay, that Y variable is our target variable. Everything else we consider as a predictor, and let it rip, right? But you have the ability to kind of like toggle a few things here, right? So you can see here, I can turn off a few predictor variables if I realize, hey, wait a second, like this employed variable doesn't matter, or it's kind of target leakage, I want to turn it off. I can kind of turn it off there, click save, and be done with it. Additionally, you have the ability to kind of toggle a few things, right? So like we have some explainability metrics to kind of look at. Like the big one that we have right now is like feature importance, which requires some extra compute. So if you wanted to turn that on for the best model, you can do that. You can also block a few algorithms, right? So if you know that like, hey, like for this model, like SVMs really, they don't do the trick here, and they often don't. We can turn that off. We can turn off the Bayes model. We just want to run like the trees and the logistic regression and that kind of thing. Also, you can kind of like say, hey, after 2 hours, let's shut it down. I don't want to have this thing running overnight. And then also you can kind of like define, how you want to set up your validation, right? If you want to do a train validation split, if you want to do K-full cross validation or something like that. And then concurrency is how many models do you want going at one time, or getting built and tested at one time. So click cancel there and just leave it at default. Click finish. And now it starts running, right? And this will take a little bit of time to run. The data set isn't huge. It's a few thousand rows. But what I do have is, if I kind of go back to automated ML, I have this finished right here on the same data set, right? So what you're left with is, and this is just kind of some technical details of what the model looks like. You have data guardrails right here that kind of tell you, wait a second, you had a pretty big imbalance. That kind of set a flag. You can kind of learn a little bit about what you might want to do with that. Looks like I'm all good with missing feature values or high cardinality. It's like I include like a key or an ID variable or something like that. And then you can kind of take a look at the actual models that were included in this. And you can see here, actually, this might not be a good one because I don't think I have the explainability. Let me go back here. The same one I was in. Yeah, okay. So you see here, kind of similar thing, right? We have the guardrails, and then we have the models, and then this is ranked based on accuracy, which was a lazy run by me. You probably really shouldn't be evaluating your binary targets on accuracy. But for whatever case, you can kind of dive into each different model and take a look at the explanations. And we have an ensemble model here, if I can take a look at the explanations. And the big thing that we have here is just really taking a look at, like, the importance, right? It's taking a look at, which of these variables are the most important for accurately predicting whether or not one of these individuals is gonna ultimately buy the loan. I will say that, like, at my last gig, Data Robot does have some more explainability features, and with Azure, that's to come, right? So you can kind of build some, like, whether you want to build partial dependence plots or cumulative gains charts or things like that. You can build that stuff with Python or R via like our SDKs or our APIs that allow you to interact with everything programmatically, but that's not yet here in the GUI. Additionally, you have the metrics, right? So this is kind of just, if you want to look at, confusion matrix, accuracy table, you can look at your AUC plot and kind of scroll down here to see what, how the model's behaving compared to a, random guess. And, by and large, it looks like it's a pretty good model here. If you look at that micro average is the one you want to look at here to kind of see what the AUC curve is looking like. So from that, there's a few other kind of logs and things like that aren't terribly important, but if you wanted to, you could kind of take the code here, bring it out, and it's all yours, and you can kind of deploy it wherever you want to deploy it. But if you wanted to, you can just kind of click this button here and deploy it, and then it winds up becoming an endpoint right here, and it's automatically registered, right? So you have this registration here, which is like kind of basically every model that I've said I wanted to hang on to and kind of understand its lineage. And then I have endpoints, and these are kind of the models that made it to the big show, right? So these are models that are now deployed on some sort of inference cluster and can be accessed via an API, right? So if I have this, like, I have a couple different bank trim models here. If I click on that one, you can see here we have this API endpoint, right? And like for any of you guys who've ever kind of hit an API endpoint, it's pretty straightforward. And even like if you haven't, like you could probably Google like how to hit an API endpoint from Python or R, and it's not difficult at all, right? To pass data back and pass data out and get some sort of prediction back. So that's kind of a long and short of it, right? So it's kind of like you kind of see it's you kind of start to see a little bit of like the allure of automated machine learning, right? Because something that might take you a long time to kind of set up the code to kind of go through the setting up the different test validation holdout and selecting different models and hyperparameter tuning and things like that, and do different types of feature engineering. All that stuff happens automatically right within automated machine learning. And then like we talked about notebooks, we talked about automated machine learning, and then we have this thing too, it's kind of like somewhere in the middle, right? So we have these designers, and what you're allowed to, what this allows you to do, and I kind of click on an example here, is you can kind of like manually build like the kind of automated machine learning thing on your own, right? So you kind of see here, you can kind of, and this is like, for those of you guys who've worked with like drag and drop, like, you know, ETL tools, you can kind of do that right here, right? You can kind of bring in a data set, you can kind of sample the data set, you have the ability to do different types of data transformations, and then you can kind of like apply a couple of different machine learning algorithms here, and you can kind of just drag and drop them, you know, right into here, and then train a model on some sort of sample data set, right? You can see here we have like, you know, you're defining your hyperparameters and things like that. So it allows for a nice little interface to kind of like run through that process of importing data. You have the ability to split it up too, and then training different models. And then you also have the flexibility to go ahead and bring in some of your own custom-made Python and R code as one of these kind of like, you know, widgets within the step. And then when you're done, you can just submit it as a, let's see if I kind of back up here, I might have a better example of it. Once you're done creating the model, you have the ability to create it as this is a real-time inference model, right? So I took that model, submitted it, and then published it. And now this is actually an API endpoint, right? So it's an application that I've posted, and it has an endpoint that I can now access from wherever. So yeah, so that's sort of the kind of high level overview on what Azure ML offers. The one other thing that's worth mentioning too is that, and I kind of briefly touched on this, she'll probably go over it a little bit more, is that, so all this stuff that I'm doing in this Azure ML portal right here, especially with automated machine learning and designer, we have R and Python SDKs, right? So you're able to kind of interact programmatically with automated machine learning and designer from R or Python. And you know, like I'm sure like a lot of the other cloud providers have, we have really great documentation and tutorials to kind of step you through your sort of hello world and how to kind of get things set up, right? So there's definitely, you know, maybe a dozen or dozens of ways to kind of skin the cat. So kind of like, you know, like just kind of like maybe like put a bow on everything here, kind of going back to, you know, this slide. You know, you can see a world where you know, maybe you already have models built in Python or R or something like that. I'm sorry, I don't know why this isn't. There we go. So, you know, maybe you live in a world where like you've kind of already done your thing here above the line, right? You've already built models in R and Python, and maybe you're using the Carrot package or using scikit-learn. It's like, hey, like I don't need automated machine learning. I'm kind of doing that anyway. I'm all good there. I mean, so like what you can do is just, you know, take the model right here that you've created as either like a pickle file from Python or an RDS, and you can just use Azure to deploy it, right? And you can kind of deploy it here. And then now it persists. You have some sort of lineage there. You have good hygiene and some flexibility to kind of access that model from wherever, or maybe vice versa, right? Maybe you like that you have Python code that is sitting on a VM somewhere that you're using, and this kind of bottom part is all taken care of for you, right? And you're like, yeah, like I like that. That's the way we set it up. It's all organized. Well, you can kind of use something like Azure ML to create your models, export that code, bring it down to here, and integrate it. And then, you know, kind of like wrapping it all up together, you can kind of do it all right within the cloud, right? And when you start to do that, you start to be able to kind of like use more services, right? Because, you know, we have a lot of customers that, you know, in this data prep pipeline, they might be using Databricks, right? So from Databricks, if you write your code, which is either Scala, Python, Java, or SQL, on top of Spark, and you can kind of just access that API, that model, right from the pipeline, or you can use that Azure Data Factory or something like that. So again, I think one of the cool things about tools like Azure Machine Learning is that they're scalable, right? So it's not you don't have to necessarily be a huge organization or a huge department to kind of like justify the spend. And there's a lot of flexibility in terms of like, which components of the entire kind of platform that you want to use. All right, I will stop there and see if there are any questions.
Well, I got a couple of questions here, Matt. Well, my first question is, can I get a copy of those slides to post along with the video here?
Yeah.
Oh, perfect. Okay, so I've got a couple of questions related to students. First of all, even if it's $1 an hour, obviously I'm looking for discounts, for my students. So, do you guys have pricing for academic uses?
So what, I put out a feeler on that probably a little too late, and let me see what I can get back on that. I do know, right? So I think first up is that if your company is a Microsoft customer or Microsoft Azure, I mean most companies are Microsoft customers. If you're an Azure customer, try to identify who your account exec is, or they might call them a specialist, and see what they can do. Because if you have some like a POC that's like kind of something that like might be like something that you can actually use in the business, there might be something they can do to kind of work with you on that. I obviously can't make any promises there. I would say that's step one. And if you know that you are a customer but you don't know who your account rep is, feel free to reach out to me and I can help you find them. I think that'll be step one. Step two is that we do have, like, if you just Google, I can maybe do it right now. If you just do a quick, I shouldn't say Google. If you do a Bing search for Azure free credit, I think it's like $200 within 30 days that you have to spend, and $200 should probably get you a pretty far way in terms of kind of testing some things out. So there's certain services that you get for free for 12 months. I don't think machine learning is one of them. Then you also get $200 credit to explore for 30 days. So I would say step one, check and see if you have a rep that you can work with and I can help you find them. Step two, see if give this a try. And then I think, step 1A would be me getting back to you, Don, to see what we can do as far as like an educational discount to maybe like extend this or something like that.
That'd be great, because my thought is, especially the 498 students, some of them in the future might want to try using this. So my second question is, what kind of training is available for this? Basically taking somebody and getting them up to speed. Like, for example, are there YouTube videos out there? Are there Coursera? Is it go to the Microsoft website? How does somebody get functional with this tool quickly?
Yeah, so I think there's a couple options there. So the first thing is that there are videos out there. So if you kind of like the first thing that we tend to kind of say is like start with the docs, right? So if you go to Azure Documentation, from here you're going to have kind of like, this is a really good jumping off point. Go to AI Machine Learning. You can kind of come down here, Azure Machine Learning. From here, there's tons of tutorials on different topics and things like that. And there's going to be linked videos as well. And then when you're actually using this in like a serious POC, that's sort of like where my job comes in, is to kind of help enable the folks that are kind of kicking the tires on it and seeing if they can actually productionalize some models. And then, kind of like the third tier there is we have like more formalized training that our customers pay for with Microsoft Premier, it's called, for getting that type of training. But yeah, and then like there's, in addition to our official documentation, there's tons of different videos that kind of some of our partners and other folks have kind of put out there to kind of walk it through. But what we tend to recommend is the kind of what gets our rubber stamp is when you go to docs.microsoft.com and then kind of start there.
Okay, and also was wondering on for your slide deck that you're going to send me, could you throw a couple of really important links like this guy here and a few other ones, so that at the very end just say, okay, here's a link to the training videos. This is the sign-on page, blah, blah, blah. Just, you know, as long as I'm asking for the world, I may as well ask for the moon too. So I just wonder if you could, you know, give us some of the important links. That would be helpful.
For sure.
Well, let's see. We got 11 people on this call. Somebody's got to have a question. I'm thinking.
I have a question.
There we go. We got a question. Who is it?
It's Kimberly. So Matt, this is more of a general question. I noticed on, you know, the slides for Azure Machine Learning, you know, they have the option where you can, I guess, use the algorithm that's already on the platform. So just in general, how often do like data scientists use that versus hard coding it into, I guess, their Python notebook?
So I'm sorry, is the question whether or not, like, so how often are they using something like an automated machine learning tool to kind of like, you know, speed themselves up versus kind of building the algorithms, like tuning and building the algorithm themselves? Is that the question?
Exactly.
Yeah, you know, I think the latter probably happens more often than the former, in terms of like a lot of data scientists haven't quite bought into like that level of abstraction yet with automated machine learning. The trend is moving in that direction though, right? And I think you know, and this is part of this is like personal preference, right? And like if you disagree with me, like that's perfectly fine, and you may very well be right. But like at the end of the day, like abstraction is good, right? Like if you think about, like, if you're familiar with like the carrot package in R, like that is a level of abstraction, right? That took some of this kind of like more arduous data science work and made it easier, right? With this package that allows you kind of really easy tune parameters and do grid search and you know sample, test, validate, holdout sets. But there's I think like this next jump that's been made to do automated machine learning hasn't quite like taken hold yet. I do think it will continue to move in that direction though, just because like I don't know there's a little bit of defensiveness from like you know data scientists and analytics folks, is because like they don't want to see like, you know, hey, we're going to teach the sales guy to do your job. 'Cause I don't think that's going to happen, right? I think at the end of the day, like our job as data scientists, we're still going to be coding a little bit, right? We're still going to be kind of doing the feature engineering and understanding the data and doing the visualizations and things like that. But a lot of what we do is you know, framing the use case the right way and framing the data the right way, understanding the problems, understanding the business and things like that. But I would say at this point, if I had to put a number on it, I would say like what I'm seeing is like 70% are still using kind of hands on the keyboard, writing Python and R, whereas 30% are using, you know, the more automated process.
Awesome, thank you.
Hi, could you talk more about containerization?
Yeah, so I mean, I'm by no means an expert, right? So like the way that we kind of do it is with Kubernetes clusters, right? So and you know the way that this works, right, is that and I can really only speak broadly to it, is that what you have is you have these clusters, which is basically a cluster of nodes or virtual machines, and then every model that you have, you put in a container and you put into one of these clusters, right? So as far as the technical specifics, I can't say like exactly what's happening. I know how to stand them up and I know how to deploy the models, but the benefit there is that like the environments are consistent and they persist, right? So every model that you deploy winds up being its own like living, breathing thing. And there's nothing in terms of like doing an upgrade to Python or an upgrade to R or like updating a package that's going to affect that model, because it's on its own in its own container, right? Like whereas like you know, 4 or 5 years ago, the way I was deploying the models is that we would take our models, we take our R scripts, we put them on a virtual machine. We would have a cron job that just automatically kicked them off once a day, once a week, once a month, wherever. But we had a bunch of models kind of living in the same virtual machine, and then like someone would like update a package for their model, and then everything else changes, right? So like now everything upstream has to get updated because they're failing, because we need to insert package double colon in front of a function because something changed, right? Whereas with the containerization, that's not a concern, right? Because everything lives inside of its own little environment that is going to be unimpacted by everything that's happening in that same cluster, but in their own separate environment. So yeah, I'm not, you know, it's actually something that I probably, I need to get more kind of intelligent on, and I want to learn more on, because it is interesting, and it is kind of like the way most folks are moving in terms of deploying models, is kind of putting them in a container, deploying them as an application, and hitting them via an API.
Hey, Matt. So I work at FedEx. We're a huge Microsoft shop, obviously, and we use Data IQ with Microsoft Azure. Do you see a lot of other companies that are Microsoft clients doing the same thing and integrating with those type of softwares as well?
So you're using, so yeah, Data IQ is a big competitor of Data Robot, right?
Yep.
So yeah, so you're using the Data IQ automated models and then deploying them from there, and then using Azure. And I guess what components of Azure are you using within like that architecture?
So that would be more of our data science team. So I'm an analyst there, and so I've been getting some background on it from them lately over the last couple months. And I knew that they were trying to get me trained on Data IQ so that way I could start using it. And I know it's tied into Azure, and they were explaining it to me a little bit. So I didn't know if you could provide a little bit of background on that. And,
I don't. Yeah, I know. I cannot tell you anything about the integration between Data IQ and Azure. I mean, I do know. Like, I mean, obviously, like, you know, Azure, like you can stand up your virtual machines and put whatever you want on it, and like nobody at Microsoft is gonna you know push you too hard to use our services. Especially if you're already kind of using Data IQ. I have played around with Data IQ a little bit. It is a great tool. It has actually a decent amount of like data prep functionality in it too.
Correct.
So my hunch is that from like a usability standpoint, you're probably just interacting mostly with Data IQ on top of like Azure servers, and that's sort of the end of it. Like you probably wouldn't be doing much of this or interacting with like the machine learning component at all. You're kind of going to be doing most of that in Data IQ.
Okay.
Anything else?
Well, looks like this might be the final question then. Unless anyone else has any other questions, I'll stop the recording here. Okay, let me